Hello, my name is Stivatus and welcome to the follow-up video on mcscript. And in this video we want to take a look at objD, that is the follow-up of mcscript, and we want to port the entire project that we did in the course over to objD. And I will show you along the way what features objD has and how it is better than mcscript. Just before we start, if you want to follow along, you can install objD easily. All the information you need is in this video right here, or also in the info card. But let's actually create the project, and therefore we want to create a new folder here, objD example, and in this folder here there will be our code. And objD is similar to mcscript. It generates the MC functions from another code base. That means you write Dart code in here, and objD automatically generates the data pack for you. So let's continue with setting up here. We open our console right here, and here we just open Visual Studio Code. So here we have it. At first we want to create an index.dart file and also a pubback.yaml. Here you define all your dependencies for the project. So you first have to give it a project name, objD example, and then we can also specify dependencies, and we just want objD here. After here you can also specify a version, but this will fetch the latest version here. So then we just save it, and over here we can see it tries to get the dependencies and downloads objD here. If this doesn't happen automatically, you can always press this button up here. So then we go back into our index.dart, and now we can start coding. So first we have to import the core, objD core, and then we want to specify a main and create a project here, which just takes a new project and also our arguments. And this project here is essentially our core now. This is the data pack that is generated. And the data pack itself is also split into packages. But let's take a look at this here first. So we have to give it a name here, objD example, and also a target path where it generates a new folder that holds your data pack. And that will just be one folder above. And then we have a generate, and this accepts a pack. That means we define a new pack here. And the pack is then essentially your namespace. So here you can also specify a name. Let's choose example. And this will then be the namespace for all your functions. So then we go into our console again and we type objD serve, our current folder, and the index.dart file. And this will now watch our files here and generate the data pack if anything changes. And we can already see it generates this pack.mcmeter file here. And here we have our data pack now. And this comes fully loaded with all the folders, so we don't have to set this up. So let's see how we can specify functions. And this is rather easy. We have a files property here, and this just accepts a list of files here, and each file is obviously a new function. So we can just say file, for example, files/main, and now we can see there is a new files folder with the main.mc function. And here we just have a child property that accepts a widget. And this widget is really the core of the objD framework, because now it is not separated just in commands like usual data pack development, but we can actually separate this in modules. That means a widget can be one command or multiple commands stitched together, and they can also exchange data from each other. And in that way we can easily reuse components and make the entire coding flow easier. But we now want to add multiple children here, and we can also do that with a widget, just for.off, and this accepts a list of more widgets and you can insert it. then we can log something here. So this will just show a console in the chat. And let's say this is the main. And if you remember in the course, we also had another function that got called from the main function here. So let's also do that. We can just specify a new file in this one function here. And we just say file.execute files.function. And this as well has a child where we just say log this is the main. And this is kind of similar to mcscript. There we could also define functions everywhere. And here we can even define a function in another function, and objD will recognize this and generate both of the functions right here. And another thing is that the second function is automatically executed and the namespace is added in front of it. So if we take a look at the code, we didn't specify the namespace here, we just defined it up here with the pack, and objD will automatically grab this thing here and give it to all the files in the pack. So you don't have to care about the namespace, and objD will handle it. And objD will also had constants, and this is rather easy in objD because we have a fully loaded programming language here. We can just say bar main text equals, and then this is kind of like a constant, and we can use it everywhere in our code. So we just include it here, and this will still work. Speaking of the constants, we also had the for loop where we could generate repeating patterns. And of course, this is also implemented in objD. We just say for, and then we automatically get the suggestions here. So we just want to go from 0 to 5. 0 is the default, and then create for each integer I a new file, and this file will be in the files directory, and it will have the name I, so just the current index. And of course we want to have a child, and there we just log the number here. And pretty fast we get these 6 files here from 0 to 5 with all the inputs here. So that's pretty much it with the files here. But now we want to run something every tick. So we have to include it somehow into the tick file. But of course objD does this automatically for us. We just have to define in our pack a main. And this just will be a file. You can call it main. And of course objD will pick up this file here and put it automatically into the tick.json, so we don't have to do anything with it. And the same goes for the load function. We just specify a file load, and currently we don't want to have a child here, so we just leave it. But of course we want to execute something every tick, so we specified a child here. And slowly but surely this whole thing here gets very complicated. And of course we can also split our code into different sections. So we will do that. We just create a new folder in this project. Let's call it files, and create a new file called main.dart. And of course we want to import our core again, and to actually get the content of this file now into our index.dart, we have to specify our own widget. That sounds crazy, but it's really simple. We just say class, and then the name of our widget, and then we want to extend the widget. And in here we now have a generate method. We can just see it in the autocompletion here, and we can press tab to use this here. We don't need this here, so now we have just this method here. And in here we return a widget. So we slowly build widgets out of widgets, and of course we had our player function. So we have to execute something as our player at the position, and we just use execute.asAdd, and then we have to import an entity here. This is a bit more complex. We just say entity, and this is the same as saying at A. And then we have here some children. This actually accepts multiple children here. And don't forget the semicolon at the end. So now we could define a player function in here, but objD will automatically detect how many children are in this list here. And depending on the amount of commands in here, it checks if it is performant to create a new file automatically. So if you have multiple children in here, this will create a new file automatically for us. So it will be more performant than just repeating execute 20 times or something. So we will come back to this soon, but first we have to implement it into the main file here. And here obviously we have to import it. So we just say import /files main.dart. And again, this is powered by autocompletion. And then we just say main file down here, and we're good to go. And this will now include everything out of this generate method here into this child property here. So then let's implement our speed block. So we just have to check if there is a block beneath the player, and we do that by using the condition here. And this is a condition.block, so we want to check for a block at the location dot relative. And here we can now specify x, y, and z. We just want the y coordinate to be -1, and the rest is filled automatically. And then of course we want a block, and this will be the block.orange concrete right here. And here you can also see this is powered by autocompletion. We get a whole list of all blocks in Minecraft, and we can just search for it and press tab to put it in here. And now we want to execute something if this condition here is true. So we just say then, and again this is a list of widgets that gets executed. And of course we just want to use an effect here. This will be of the effect type .speed with the entity of entity.selected. And we also have a duration of 1 second, an amplifier of 5, and we don't want to show particles, so we set show particles to false. The usual effect command is a bit complicated, but with objD you can really see the arguments and which value fits which argument here. You can see the entity, the duration, and the order also doesn't matter. Let's take a look at the main.mc function here, and we can see here is our long command with our effect give here. And we have to repeat the same for the jump boost. So we just take this part here and copy it down. Here we have it. And this should be a concrete. And then we want to give jump boost. And this is also copied into the main.mc function here. So let's see if this actually works. And yes, we get the speed effect. And the jump boost also works. And again, what you can do is pack this whole thing here into a new widget, into a new file, and just specify the effect type or the block. And this would make this a bit easier here. And of course, we also want to implement our wall run here, and therefore we need a tag. And the tag is also pretty simple. We just specify the name of the tag. For example, is wall, and then the entity.selected, and this will just add the tag to our entity. And we can also call an add here. We can also remove it, and we can also remove it only if it exists. We can actually save this tag here as a constant, as a variable. So here we just say tag is wall equals our whole tag here. And now we can just use our variable here and use it in our code instead of this long thing here. So for our wall run, we want to check around the player. So we use a around location widget here. And this will just give us all the locations around the current location. We have to give it the distance. That's 1 at the moment. And we also don't want to have top, and it should also not check the bottom. And then we have a build function here. We just get the current location, and we just want to check if at the current location here around the player, if there is a block with pink concrete. And we've done that already. That's just the condition.block here with the location here, and also the block of block.pink concrete here. And then we just want to add isWall. So we just say isWall.add. And we will also do that with the facing location. So just one block above the other location. So we just use execute.positioned, and then we can give it a location.relative and set the y to 1. Then again we have children here, and we can just copy our around location. Looks a bit ugly, but there's a cool trick. We can just right click. We can just say format document here, and this will align it properly. So now the player has this isWall tag if around the player is this pink concrete, but we actually have to do something with it. And we want to do it before the tag is added at the end here. So we just use the space right here, because the order is kept in the main.mc function. So here we want to use isWall remove if exists. So it checks if the tag is existent and remove this then. And here we also have the option to specify a widget that should execute before the tag is removed. And here we want to place a barrier below the player if there is no block. So obviously we have to check if there is a block beneath the player, condition.block again, location.relative y minus 1, and the block should be block.air, and then we want to set block. And I also forgot a comma here, so it automatically gave me an error here. This was also not possible with mcscript. So we want to set block something, so we just use the set block widget with the block.barrier and the location of location minus 1. And we could also save this location here in a variable up here, so we don't have to type it. But now we have already done it. So let's see if this works in Minecraft. We reload the game, and yes, we get this war run effect here, but the barriers also stay there. That's not convenient, so we have to clear the barriers again. And of course, we just do that with a simple build command. And we want to replace something. And of course, we want to replace it with air again. The replace should be block.barrier barrier here. And of course, we also have to give it a sort of location. And therefore, there is the parameter area. So we just say area, a new area, and we want it from locations. And here we can now specify 2 locations, log1 and log2. Let's do that really quick. Location x2, y2, z2, and the whole thing again, but with negative numbers. So there we go. That should now clear up our barriers here. And yes, they are gone. So there's just one barrier directly beneath us. And now we are pretty much finished with the block detection here. So let's move on to the raycasting part. Of course, there is also raycasting in objD, and it is even simpler, and you can customize it much more. So let's go into our index again, and we first want to detect a click event on a carrot on a stick. Well, in objD, it's as simple as defining the modules here, and then we can use a click event module. So then we can just say on click, and here we want a new custom widget. So we just say new files here in the files. So we just say in the files here, new file, click.dart, import our core again, and define a new click file which extends the widget and has our generate method which returns null for the moment. And of course we have to import it up here, so we just say files click, and then we can use the click file right here in our onClick handler. And it is as simple as that. And we can see in the main.mc function there is now this objD click here added, and we also have a new folder in our project that is called events, and there we have our objD click mc function where our click.dart content now goes to. And on a click we just want to raycast. We just use the Raycast widget here, specify an entity to go from, and we use the selected again because the click event actually gives us the entity that clicked the carrot on a stick. And on hit we want to just show a particle with particle type .flame and the location of location.here. This is a bit simpler than relative and set everything to 0. So let's use that for the moment, and you can see this Raycast here. Another special widget. We just define it once here and it generates multiple files here, and it handles all the complex logic for us, so we can just use it like that here in our project. And let's check it out. We have our carrot on a stick here, and when we have our glass block here, we can see the particles that are directly at the location that we aim at. So let's do our platform trick here again. Yeah, now the video got unusable because I forgot to switch the recording mode and you aren't able to see what I'm doing. So this part with the floating platform is missing. I apologize for that, but I think for a small demo it's already worth it. Nevertheless, you can find the full source code on my GitHub along with the mcscript code, of course. Back to you. Let's save that. Let it generate automatically and reload the game here. And there we go, it moves if we drag it over here. And this was it with this objD project here. Also all the parts of objD are open source. You can just take a look at the repository. And if you're really bored, you can also read the documentation here, where you can read how to install it, all the basic widgets like a file, and how all the commands are implemented right here. There's also a whole section about text and strings. You can also take a look at that in this video up here. And then you have these generators here, which include raycasting, a for each loop, holograms, or a timer, for example. And last but not least, I also coded some APIs. With objD already, there is a whole crafting API that works out of the box, and a dungeon API. That's also some possibilities here. I will link this documentation in the description. You can read a lot about objD. And here's also the whole playlist with objD tutorials, a weekly widget series, and much more. This was it. We'll see us in the next video.